Hello everyone, you are listening to Professor Rajendra Tadakhe, Department of Mechanical Engineering, Marathwada Mitra Mandal's College of Engineering, Karvenagar, Pune, and I am the course instructor for Theory of Machines 1. In the previous lecture, we have started with velocity analysis of the mechanism by using a relative velocity method. So in today's lecture, we are going to solve one problem based on the velocity analysis using relative velocity method, and we will be analyzing a single slider crank mechanism. Let's start with the second problem on the velocity analysis by relative velocity method. So in which we are going to consider a slider crank mechanism. So here we are having the problem statement. So I read the problem statement. An IC engine mechanism as shown in the figure 1, in which crank AB rotates at 600 rpm. The length of crank AB is 0.5 meter and the connecting rod is 2 meter long. When the crank is turned 45 degree from the inner dead center, find velocity of the piston P, angular velocity of the connecting rod BP, and third is velocity of point D on the connecting rod, which is at a distance of 0.5 meter from B. So in this diagram, the length of AB is given, which is a crank, that is 0.5 meter. Then BP is the connecting rod, whose length is mentioned as 2 meter. Then the position of crank with respect to IDC is given, which is 45 degree. That is, it is making an inclination of 45 degree with the line of stroke or the line of action. And P is the slider. So let's start with the solution. So in the step number 1, what we have to do is we have to write the given data from the problem statement. So the speed of crank is given, which is 600 rpm. Then the length of the crank is given, which is 0.5 meter. Length of connecting rod is given, which is 2 meter. These are the given things in the problem statement. And now we are asked to find out angular velocity of link PB, that is the angular velocity of the connecting rod we have to find out. Then second is we have to find velocity of piston, then velocity of point D, which is on the connecting rod at a distance of 0.5 meter from the point B. So in the step number 3, we have to draw the configuration diagram. So configuration diagram means we have to draw the slider crank mechanism as per the dimensions provided in the problem statement. And as discussed earlier or in the previous lecture, when we are having the two large dimensions for the given mechanism, then we have to scale down the dimension. So in this problem statement, we are having the length of connecting rod as 0.5 meter and length of crank as 0.5 meter and length of connecting rod as 2 meter. So these dimensions are too large. We cannot draw this dimension on the sheet. So what we will do, we will scale down these dimensions. So for configuration diagram, we will consider that 1 centimeter length will represent a 0.25 meter distance or a length of 0.25 meter. So according to this scale, we have to draw this configuration diagram. So let me explain this configuration diagram in detail. So first of all, we have to take this fixed point A. Then length of crank, that is length of AB, is mentioned, which is 0.5 meter. But according to the scale which we have chosen, which is 1 centimeter is equal to 0.25 meter, it means 0.5 meter will represent a distance of 2 centimeter in the configuration diagram. Means in actually, you have to draw crank AB of length 2 centimeter, but original dimension of it is 0.5 meter. And this AB is making an inclination of 45 degree. So with this, we'll get the point B. Then next, we have to locate the point P. So how to locate the point P? Draw a line passing through the point A. Then take a distance equal to the length of connecting rod in the compass. So here length of connecting rod is 2 meter. But according to the given dimension, this 2 meter is equivalent to a 8 centimeter. So in the compass we have to take a distance of 8 centimeter. Then we'll keep one point at B and we'll mark the arc on the line of stroke. So which will give you point P. So in this way we'll get the location of point P. Then we have to locate the position of point D on the connecting rod. So again it is very simple. In the problem statement it is mentioned that it is at a distance of 0.5 meter from B. So 0.5 meter means how much it is in centimeter? According to the given scale, it is 2 centimeter from point B. So at a distance of 2 centimeter, we have to locate point D. So in this way we will complete our configuration diagram. Now in the step number 4, we have to calculate the linear velocity of the input link. That is, we are having an input link here in this problem as AB, which is a crank. So for this crank we have to calculate its linear velocity. But to calculate the linear velocity, first we have to calculate its angular velocity, and to calculate the angular velocity we are provided with the RPM of the crank. So let's start with the step number 4. Angular velocity of the link AB, which we calculate by using the formula omega is equal to 2 pi n by 60. So this formula we are writing for link AB. So omega AB is equal to 2 pi n AB divided by 60. Now we have to put the corresponding values in this. That is, put value of NAB as 600 RPM. Then finally we get omega AB as 62.831 radian per second. So once we get the value of angular velocity, then we have to calculate the linear velocity of link AB. So to calculate the linear velocity of the link AB, we are going to use a standard basic formula which correlates angular velocity and the linear velocity, which is V is equal to R omega. In which V is representing a linear velocity, R is representing a radius, and omega is representing the angular velocity. So this formula we are going to write for the crank. So VB is equal to VBA into radius means the length of the link we have to consider. That's why we have written as BA into omega BA, which we have found in the earlier step. So put the corresponding values. So finally we get the linear velocity of point D as 31.415 meter per second. So now we know the linear velocity of the input link, which is 31.415 meter per second. Next step is to construct the velocity polygon or the velocity diagram. So to start with, what we have to do is we have to take a look at the velocity of input link, that is linear velocity, so which is 31.415 meter per second. So by considering this value of linear velocity for the input link, we have to choose a particular scale to construct the velocity polygon. So here we are considering 1 centimeter will represent a linear velocity of 6 meter per second. Then we have to take a one point which is called as pole of the velocity polygon. So this we have to represent by all the fixed point from the configuration diagram. So here we are having A as a fixed point. So name this point as A. So this is pole position for the velocity polygon. Now go to the input link, for which the magnitude and the direction both are known. Magnitude is 31.415 meter per second and the direction is perpendicular to the link BA. So here I want to tell you one thing. So whenever we are drawing the direction of the velocity vector, then it is always perpendicular to the link, and for the slider it is always along the line of stroke, because it is having a linear velocity at all the times. So the magnitude of AB is known, which is 31.415. So for this magnitude and considering this scale, draw a velocity vector which will represent the velocity of point B and name it as VB is equal to VBA. So this velocity vector is nothing but it shows the direction and magnitude of this velocity 31.415, and this length will be equal to 31.415 divided by 6. So that will give you some distance, and that distance is nothing but the length of vector AB, and this direction is perpendicular to the link BA. So in this way we have drawn the velocity vector of input link BA or crank. And the meaning of this VBA is that the velocity of point B observed from fixed point A. As the point A is fixed in nature, so we can simply indicate by VB. Now next we have to move to the connecting rod PB. So we don't know the magnitude of the linear velocity for the connecting rod, but what we know is its direction. So it is perpendicular to the link PB. So here we are having the point B. So what we have to do is we have to draw the perpendicular to this link BP passing through point B. So here we have drawn the perpendicular to the link BP passing through point B, and length is unknown but the direction is known. Then consider the slider. So slider is having a linear motion along the line of stroke which is passing through the point A. So here we are having point A, so we have to draw a vector or the velocity vector which will represent the velocity of point P. So if as the rotation of the crank is clockwise, so in this situation what will happen? This P will move towards A. So it will be towards right hand side. So draw the velocity vector from point A in such a way that it is parallel to this line of stroke and will pass through the point A. So when you are drawing this, then it will intersect to the velocity vector of the connecting rod, and this point of intersection is nothing but the point P. So this BP is representing a linear velocity of connecting rod, and this AP is representing a linear velocity of piston. So this is VPB, that is velocity of point P observed from point B, and here it is VP, that is velocity of point P observed from A. You can also write VP as VPA, but A is fixed, so that's why we are considering it as an absolute velocity. Now we have to locate the point D in the velocity polygon. So for that, what we have to see, the point D will divide the vector BP in the same ratio as it divides the connecting rod BP. So to locate the point D in the velocity polygon, we can write that BP upon BD is equal to small bp upon BD. So from this we can write the expression for BD. Then put the corresponding values, and once we put the corresponding value, we get the value of BD. BD means the location of point D from point B. So from this point B, we have to mark the point D at a distance of 0.925 centimeter. Okay, so we'll mark this point. So here we have marked the point at a distance of 0.925 centimeter from B point, and then to know its velocity with respect to point A, we will connect. So this is nothing but the velocity of point D observed from point A. So this completes the velocity polygon for the given slider crank mechanism. Now we are left with these three things. That is, we have to calculate the angular velocity of link PB, then velocity of piston, and the velocity of point D. So to find the velocity of piston VP and the velocity of point D, it is very simple. So to get the value of VP, what we have to do is just measure the length of this and multiply by scale. So it will give you the linear velocity of the piston. Similarly, to know the velocity of point D with respect to point A, measure the length of this and multiply by scale. So we will get the velocity of point D as well. But to calculate the angular velocity of PB, first of all, we have to measure the length of point B, vector BP, then multiply by scale. So it will give you a linear velocity, and once we get the linear velocity, we have to use the formula V is equal to R omega. So once we use the formula V is equal to R omega, as V is known, R is known, where R stands for the length of the connecting rod and omega can be calculated. So let's start with the angular velocity of the connecting rod, which is PB. Then from velocity polygon, we can say that the VPB, that is velocity of point P with respect to the, is the length of vector BP multiplied by scale. So it is 22.2 meter per second. So here 3.7 is nothing but the length of this vector we have measured, that is vector BP, and into 6, because we have considered the scale for the velocity diagram or the velocity polygon as 1 centimeter is equal to 6 meter per second. That's why it is multiplied by 6. So that's why we get the velocity of connecting rod, that is the linear velocity of connecting rod at a given instant, as 22.2 meter per second. Now to calculate the angular velocity of connecting rod, just use this simple formula V is equal to R omega. So VPB, R means the length of the connecting rod, which is PB, and omega PB. So put the corresponding values in this. So this value we have calculated in the earlier step, which is 22.2 meter per second. Then PB is 2 meter and into omega PB. So we get the connecting rod angular velocity as 11.1 radian per second. Next, we have to calculate the velocity of the piston VP. So just measure the length of AP and multiply by scale. So it is 4.4 centimeter length, multiply by 6. So it will give you the velocity of piston, which is 26.4 meter per second. And finally, to get the velocity of point D, what we have to do is measure this length AB and multiply by scale. So length of vector AD is 4.8 and scale is 6 meter per second. So into 6. So it gives the value of velocity of point D as 28.8 meter per second. So these are the answers, or these are the things which was asked in the problem statement. So this is the end of velocity analysis of slider crank mechanism by using a relative velocity method.